Okay, this is a guided tour of what I've done so far on the Vernon Smart Solar circuit board. As you can see, I've kind of zoomed in on the display, and of course you can see the display says Vernon Smart Solar on it. Now I'm going to widen the view out a little bit here and raise this up. And in the background you can see the circuit board. So far I have installed the two 575 shift registers that interface with the SPI port, that's the serial peripheral interface, to present parallel data and strobe the data into the parallel LCD display. The processor module has been installed, as has the 2K contrast pot that allows adjustment for the contrast on the display. In the back here we have the 7805 5-volt regulator that provides 5-volt power for the processor and associated logic. It operates off a 12-volt power supply for the time being. This is the reset button, so it can be reset. I don't have the energy metering, all of the parts for the energy metering system yet. That will go here on the back of the board and consists of an Analog Devices ADE 7763. That is a surface mount chip, and I had it mounted on a 20 pin dip adapter so I can solder it on this board. I have a 20 pin dip socket on the board. I'm not that good at soldering surface mount. When the energy chip is installed, it will be able to measure current, voltage, volt amperes reactive, watts, and accumulated energy or kilowatt hours. This of course is on the AC side of the inverter, the output of the inverter. It will also be able to measure DC voltage and current from the solar panel, and this will adapt to any size array because the DC, the multiplier and the shunt of course can scale any kind of DC power down to measurable quantities, and with appropriate CT and PT ratio I can scale the AC down so the AC can be measured. I'll therefore be able to calculate the efficiency of the solar panel by, of course, the ratio of the DC in, the efficiency of the inverter, excuse me, by the ratio of the DC in and the AC out of the inverter. Eventually, I'm going to add another DC channel for tracking, where it will measure an error voltage of two splayed solar cells on the sides of the panel, and that will provide a tracking signal to keep the array aimed at the sun. That provision is not on this circuit board, however. I'm now going to take the camera off here, give you a more guided tour. There is a display, and there is the microprocessor module from Technological Arts. There is the voltage regulator. There is the 74595s that provide the interface to the display. You can see the contrast pot. And this will normally not use the display. The display will be on there and functioning, but the data will be sent out an RS-232 port, which is not wired in yet, and that data will be sent via a wireless link to this mini server back here. It's a NetBurner internet server, and that will allow the data to be presented on a web page so you can view your solar performance from anywhere in the world. And that's what we've got done now. You can see the empty part there where all the rest of the energy and metering parts have to go. Thanks for watching.